All right, welcome everybody to another Capital Technology LinkedIn Live. Today with us we have Dr. Mohammed, who is going to talk about quantum entanglement. We also have Dr. Ian McAndrew, who is the Dean of Doctoral Programs here at Capital Technology University. And in the quantum area, we do offer an online doctorate in quantum computing and a master's degree in research in quantum computing, which Dr. Mohammed is a chair of the dissertation and thesis for some of those students involved in that program. So I'm going to turn it over to you, Dr. Mohammed. Start talking about quantum entanglement.
Okay, well, thank you so much, President Sims, and it's a great opportunity to be with the legendary Dr. Ian McAndrew, who happens to be the Dean of Artificial Intelligence and Quantum Computing. So, this topic, the quantum entanglement that I would like to speak at this moment, the Big Bang Theory has actually brought it in for the masses of the example that was given of the Schrodinger's cat. There are several other examples. Elaine Aspect and Jean Delbert in 1982 published a famous paper where they tested the Bell's inequality using time varying analysis on the photons which are entangled. It's another example that came to very near and dear to my heart, that if I order a shirt and a trouser to Amazon and it comes in two different Amazon boxes, which are non-labeled except my name and address, then I have two boxes, and the dilemma is which one is which. Have I been receiving the shirts and shirt, or shirt and trouser, or trouser and trouser? However, when I open up one box and I find the shirt in it, then it's a known information for me that the other box has the trouser. And if I open the second box and get a trouser, then the information is complete. That is exactly as switching on a light button on or off. And if there are two lights in my room, I would switch on both buttons at the same time. However, that's zero and one. That's a finite state automaton. What is the next level of finite state? That becomes quantum computing or qubit state change. That can be, I have a switch that goes from 0 to 1. However, there's a dimmer associated. And dimmer means once the light switches on, then there is a certain current that is being coming in my bulb or tube light, and that can glow more or less at the same time when I move the dial. The idea is the 300 qubits is equal to 2 and then 90 zeros after that, standard bits of a computer. So you can imagine the odds that if we use the quantum computing rather than standard finite state automaton, where we have 0 or 1, a start state and an end state, and a state can repeat itself. That means we are now changing the dimension of the spooky side that Einstein mentioned. The best thing I have found in the quantum entanglement, it's applicable in databases, cryptography, cybersecurity. It also is applicable in the machine learning at the level of quantum machine learning, which has been discussed by Deng, Lee, and Sarma in quantum entanglement in neural network state. That paper has been published in 2017. I would suggest you to look into that. That's where they discuss the quantum entanglement in the arena of neural networks, whether these are convolutional neural networks or these are the standard machine learning networks, which can be RNN and ANN. The quantum entanglement also impacts in the machine learning or artificial intelligence at a level when we are dealing with the restricted Boltzmann machines and fully connected neural networks. allow us to work at the same time in tandem, in parallel, when they are in motion. That means if a soccer ball is on the ground, then A, B, C are the three coordinates, X, Y, and Z. We know exactly where the soccer ball is, or a football if it is on the ground. However, as soon as we hit it, and there are three players hitting three balls to the goal, there is a fourth dimension that is added, that XYZ in time. That's where the change occurs at that moment. So in 2010, the first published book in 2000 by the Cambridge University Press, Computation and Quantum Information by Nielsen and Chuang, discusses in quite depth the phenomena of quantum entanglement. I would suggest you to look into this very carefully, as Google Quantum AI, IBM's quantum uh, research, Microsoft's quantum research, and Amazon Braket are the major players which are looking at working with the quantum entanglement, quantum processing, the state change. There are few startups I would suggest you to look into is Rigetti Computing, IonQ, D-Wave Systems, Xanadu, Honeywell Quantum Solutions, and they are leveraging the trapped ion technology in the Honeywell Quantum Solutions that is, as per my knowledge, at this moment. There are research institutions and government labs which are looking into that. That's national laboratories and several universities like MIT, Caltech, and ETH Zurich is working on the quantum computation and quantum entanglement in quite depth. In the international efforts, the European Union's quantum flagship is a multi-billion euro initiative that aims secure Europe's leading role in quantum technologies, along with the United States and Canada's efforts. China's National Laboratory of Quantum Informatics or Information Sciences is another one. I would suggest you look into this. The When we are working with any given problem set in a standard bit, which is 0 or 1, and then we start making a decision when we hit a T while driving a car, then either we go right or left. Quantum computing allows us to actually look at the unknown. Donald Rumsfeld famously said, "There are knowns, there are known knowns, there are known unknowns, there are unknowns, and there are unknown unknowns." So quantum computation takes us in the unknown unknowns with potential contexts where we have to go and explore the details. And this is an area that I would suggest you to look into more depth, because quantum computing at this moment is in R&D phase. It will eventually go at a level where it'll start producing results. The quantum cryptography is another one that goes to the next level as the Bitcoin or Ethereum backend algorithms, where a standard Bitcoin, the ID generated of a Bitcoin, let me retrace my steps, when is given to someone as a public key and a private key is sent, that means the multiplication of those keys generates a result. If that result is not matched, you don't have a Bitcoin. So you have to retrace from a given key the two keys which are absolutely different, but when multiplied, results in a token or in a cryptography cryptographical result. So this is an area that I would suggest you to look into to understand where we are heading. The quantum entanglement is still a mystery for standard normal research folks. And let's say if I have to explain it to a child, there are two special socks, identical in every way. Now close your eyes and toss those socks. You will find both socks because you have one sock which you found first, and you now know that the same color sock would be somewhere in the room, and that's just a simple test. Whereas if you have two coins, one in each hand, that is again the same example of X, Y, and Z. Your one hand, right hand might have the coin's head, and your left hand might have the coin's tail. That's X, Y, and Z, and you know their locales, their context. However, when you throw them off in the air, we don't know what their position is. That's called superposition. And when we work with the ideas that these two coins are entangled, if they are both going at the same spin, heads first, tails after, and then if we take these two coins separate on a wide distance, at one time, if we know that this, my left hand took a coin that I threw in the air, is now going tails head first, it means that a third force has been implemented. It might be a wave, it might be wind, it might be sound wave that's impacting. The other coin that I had raised in by its right hand would actually depict this scenario of my left hand. That's why it is also called by Einstein's spooky thing. This super fast computers, imagine the computers that can solve complex problems in seconds by harnessing the power of entangled particles. Unbreakable codes, the unique connection of entangled particles could create codes impossible to crack. Teleportation, obviously, Star Trek has discussed teleportation at a big level, but information teleportation definitely is possible with quantum entanglement. So I would suggest you to look into the Capital Technology University and see the programs that we have, and we would love to hear from you that you can actually come and talk to us about. I would hand over back to Dr. Ian McAndrew. Hopefully this helps.
Thank you, Dr. Mohammed. If we look at the entanglement and we think about qubits, theoretically, people have said and expressed a view that it's possible maybe in one fistful of lead could, in principle, store every known piece of information that has ever been found, stored, or used by mankind. If we think of that as a starting point, and we follow that on from your description about how we could make unbreakable encryption, or we could have a risk of encryption being broken and different things, do you think people generally are aware of the potential of the future of quantum computing in the next 5 years? And if you were to share one of your views, and if you were to say what the biggest risk and the biggest positive there is to society, would you have an answer that you could share with us?
Certainly, the standard positions as we know as an X and Y or 0 or 1, that's the standard bits. The question is multifold that Dr. Ian McAndrew posed. The superposition, as of now, we are dealing with the three dimensions with the time variation. The very first uh, paper that I discussed is Alain in Paris that they have came up, where they did put the Bell inequality of time variations or time analyzers. However, there can be two different time zones. The same experiment has been repeated again and again on financials, for example, financial charts. The time we are working with the quantum bits or the qubits, at same time at two different places, one information can be teleported theoretically at this moment on the other side of the earth. And that is where the risk comes in of exposing the position of certain stock or mutual fund or something, if it is international. On the other side, if the information had been produced and provided to the other side, that's technically a risk. How we can control it? We can transport simultaneously a lock that is a quantum lock and can be opened by the quantum cryptographic key rather than the regular standard SHA 256 and all that. Hopefully, this helps.
Well, indeed it does. And I always think that sometimes people are expecting the best buys will be, excuse me, will be having a quantum computer, something like a larger laptop than what we have. I think people don't understand or appreciate, the parallel approaches. And we use the phrase quantum computing, and people don't visualize what they mean. The storage of data, the transmission of data, and even how we use that data is perhaps being held back by people's visualization because we're using the word computer. I've had a researcher say to me once, we should be calling it quantum engineering or quantum machining, because that is something where people will separate their views from the problems that we have. Do you think this is a reasonable philosophy to be looking at?
Yes and no in a superposition way. If it is database that has been established, the database management system is a curriculum that has been established for 3 or 4 decades now. When we are working with the distributed databases, we have to send a query in terms of structured query language, writing a command to extract the answer. However, when we are in the parallel dimension and we are given the equal information, and if it is large language model, which is using the quantum entanglement on the back end, and is producing for, let's say, OpenAI or Grok or Bard, it's a highly likely possibility that one query has been generated, even though it was asked in 3 or 4 different languages for the certain extraction of the information out. So far, compute is extensively expensive, but with quantum computing and qubits use, we will be reaching there. I'm pretty sure in 5 to 10 years time frame, we will be there. These are my thoughts.
Thank you. I always think, where I'm looking at this particular aspect has been primarily over the last few years with the harmonics of prime numbers. And this has been with a particular student, and we've been researching this and had a lot of success in terms of what we're looking at. But it's a very small corner of what we're doing with quantum. And I'm thinking if someone like yourself that is chairing quantum research with PhDs and your own individual research and enthusiasm, we're at the dawn of a brave new world, I would say. And I always think, having been chairing PhD students for about 30 years now and enjoying all of it, I think we're now in a position where people like yourself, or even students that you're chairing, are at the ability to break the threshold or reach new sort of areas of knowledge which are going to be fundamentally beneficial to humans. And I think this is one of the things that just adds to the area and working with research in that. It could be, for example, that in 3 years' time, one of your students that you have been chairing could be nominated for something like a Nobel Prize because it is such a big step forward in this area. How do you see your role in supporting this and enabling this, considering you are a core player yourself?
That's a phenomenal thought. And thank you for giving me a chance to actually work with these students. I do have a student who's working with me, and we are coming up with the research that has been conducted in the asteroid mining, for example. And that's a reality. That's a need. There are 4 or 5 big space programs that we are running at this moment across the globe. And that of my student has come up with a unique, novel idea, which I asked him to pretty much either copyright and make sure that it has been recorded in the university system. So we know that where we are heading with it. The idea is if we have 2 parallel drill bits, one is here on Earth, one is an asteroid that we deploy. However, they are quantum entangled. The movement of one bit will tell us on that asteroid what has been mined at the same time. We don't have to physically put this Earth bit to hit something and extract. It's rather the same motion with the potential of the other motion in the space. By making sure that the time analyzers are applied on both, we can view. Obviously, we cannot send cameras on that bit on the asteroid, which is drilling. So this is the quantum teleportation that we are looking at this very moment with my master student. I have already suggested him to go ahead and do the PhD on this. This is a novel idea which can be utilized, and that can be applicable even on the Earth. We are heading to the Mars. We cannot just, we have to wait for the rays to come back to us so we can utilize. Why can't we do the same parallel experimentation here first in two distinct machines, quantumly entangled, not in terms of photons, rather algorithms to produce the same result? Yes, we are heading towards that area pretty fast.
Thank you. I'd just like to draw a small parallel here, and it's what I often say when we're looking at research and the complex science of research. And for those of you, if we remember the very first Jurassic Park film, and the tour had seen the dinosaurs for the first time, and they came back for this meal, everyone was excited except for Dr. Ian Malcolm, who was the mathematician. And I always think about this, and I'm wondering how it fits in here, because he said, instead of asking yourself, can we do this? We should be asking ourselves first the question, should we be doing this? And I think how this relates to quantum in this case is that we are potentially using the science, the mathematics, the physics to solve some of these problems and make significant breakthroughs. Are we in danger of being 2-3 steps ahead of everyone else? And I mean, for example, the legal side, the ethics side, the practicality side, and even the economic side of how things work. Is there a danger with this subject that we could just be too successful and the world isn't ready for it in any shape or form? And should we be encouraging this other type of research? Because people in quantum often think of people good at mathematics, science, and physics and things. Are we perhaps at risk of leaving out the people with the humanities focus that we also need for this to be realistic?
This is the most intriguing question. A couple of people asked me while I was in Washington, D.C., giving a lecture at GovAI and last month. The question came that you teach quantum computing, because they knew my background. And that was more ethical arena that people were asking me these questions. Two people actually asked me. The risk is real. There are no authorities or committees which are working at this moment to even address that risk. They are dealing with the large language models and generative AI and all that risks. However, when we conduct research, we have possible two outcomes. It's good research, it's bad research. And if it is bad research, how can it be positively utilized to solve some other area which we might not have looked at? So if it's a good research, we already had an hypothesis that we might get this good side of the research. But the bad research is technically not a bad research. It's research which had gone on a different route. And that's where we start looking into the ethical implication, the economical implication, and the potential risk aversion that comes by learning. These are my 2 cents. We need to look at that very carefully, that if they're going to be having any adverse effects on anything else which is not directly related to the potential outcome.
Thank you. I mean, as before I hand back to both of you, Dr. Sims, President Sims, and yourself, I think this is where the wonders of modern technology and different things. And You know, being involved as the dean of a doctoral program and seeing students successful has always been satisfying for me. And my very last student, who was my 187th student who completed, gave me just as much as a buzz as the very first student that I helped get through this wonderful process and to achieve the goal. I think it's amazing that we can use technology, we can use the way that we're working now to ensure that students are supported in the best ways that they can be. And Dr. Mohammad is one of those experts that is not only a pleasure and a delight to work with, but offers students that may not traditionally be geographically locally to get on and work with people like this. What do you say to those people that have the potential to support and are timid to take the first step to be a chair and to work with research and really put your head above them and say, this is what we're working on. Come and challenge me if you can, and being confident that what I've delivered is substantial in the research world. How do you encourage the people to come and support us, and particularly yourself, to make this move forward even faster?
The best suggestion I always give to my students that tomorrow never comes. It's today, what you're finding today, and which we think is tomorrow. We should not be receding, we should be proceeding. What's the next level? Do not be stale. I also give my example. I started my first PhD when I turned 40. I graduated with my second PhD from University of North Dakota when I was 49. So if I can do it, anyone can do it. You do not stalemate. You go for checkmate and then go for next chess game.
I like that summary. I think that captures a lot in there, and I probably use that and quote you in the future and everything. I'm cognizant that the time is now passing. And President Sims, do you have any added parts or observations that you would like to add in the discussion of Dr. Mohammad and how he's been sharing his knowledge and wisdom?
I think it's a great 30-minute coverage of quantum and where we as a university also fit in the picture. Um, there's the quantum computing degrees, which we were discussing today, which include both the master's and doctorate, and they're, for those listening, they're online, and we specialize in only STEM, science, technology, engineering, math, programming at Capital Technology University. And if you're working full time, one of the nice things about it, whether it's a master's of research or doctoral degree online, is that individuals like Dr. Mohammed, who are experts in their field, are assigned to you at the beginning of your start of either degree, master's or doc, and they work with you in a one-on-one mentored research model. So we're identifying experts in the fields that you study with us, and we have over 40 doctoral degrees and about the same in master's degrees. And so you're getting one-on-one mentorship from somebody in the field that matches your interest in that area, whether it's quantum computing, artificial intelligence, cybersecurity. There's a whole array of them. I invite you to check out our website, captechu.edu. You can see all the degrees. But along with that, I really think, to me, the real exciting part of whether it's online doctorate or online master's of research is that you can use a project that you're working at your company as your focus. And therefore, the ability for you to go back to your employer and seek a solution to a problem that you're working on and still use that same problem to write either your master's thesis or your doctoral dissertation is a wonderful blend of education and direct application to your work environment. And that's what we specialize here at Capital Technology University. And Dr. Ian McAndrew is our Dean of Doctoral Programs. He also oversees our Masters in Research, and we also have a few degrees called Masters of Philosophy, which incorporate some coursework with your thesis as well. And I certainly encourage you to reach out to him. You can do so through going to our website and going to the program. I know Dr. Mohammed, he's an adjunct professor for us as well, but I'm sure you could easily contact him through LinkedIn. You just look him up and access him. So I want to thank you, and I want to thank everybody listening today to our next. This was our LinkedIn Live for today. Is if there's anything else that either one of you want to mention before we end, please do so.
I'd just like to quickly express my thanks to Dr. Mohammad for giving up his time and sharing his insight and wisdom for those that are interested not only in this subject, but potentially interested in this subject. And thank you, sir.
Thank you indeed.